So here we have the good old Muller battery. It's a 200 ampere hour lithium iron phosphate 12 volt battery, and I have already removed the battery pack from this box because I think the Daly BMS is toast. I had this battery connected to the PIDA inverter and it powered my hot water system. I have done this quite a few times, but this time it was a bit different. It worked only for an hour and then the heating stopped. And I thought the battery is empty or the inverter is overloaded or overheated or something, but none of that is the case. So let me show you what happened. Okay, let's see if we can connect to this BMS. That could be it. No. All right, let's try again. Yes, we are connected. So we are now connected to the Daly BMS here via Bluetooth. And as you can see, the maximum cell voltage is 3.988 volts. Ooh, this is a 4S lithium iron phosphate battery with 200 ampere hours each cell. Minimum voltage 2.418 volts only. Charge and discharge MOSFETs have turned off. Got a cell difference of 1.57 volts. Cell voltage high level, cell voltage low level, low state of charge level. Everything is f***ed up. Cell number 1 is low, cell number 2 is high, number 3 and 4 are okay. Yeah, that's exactly how I found this battery after using it for a while. I had fully charged it with this one solar panel there. And I wanted to use this energy with a PIDA inverter hooked up to my hot water system. Yeah, I've got a transfer switch in there and I can run the hot water from the grid, or I can flick the switch and it runs from an external energy source like a generator or another inverter with a battery. And this one was running for 1.5 kilowatt hours and then it stopped. And I thought the battery is empty, but it would have been a bit premature. So I checked on it and could see that the BMS has turned off. I thought it was an overheating issue, but no, it's not. And now as you can see, the BMS has now disconnected again and won't come alive until I press the Bluetooth button here on this module. And then after a while, there it is again. It's back alive, we can connect to it. And we've got the same shit again, yeah? One battery cell is really high, the other one is really low, the other two are fine. And I got really scared and thought something has happened to this battery and some of the cells have now reverse voltage or something, because there's also an active balancer usually connected with this battery which runs 24/7. Yeah, it balances all the time. And after fully charging the battery, I checked the cells here on the BMS and they were all at 3.48 volts or something, and the battery was actually pretty well balanced thanks to this active balancer. There it drops out again. And I've used this method quite a few times to fully charge this battery with a solar panel and then use the PIDA inverter to heat up the hot water. But yeah, definitely something is going on now, and I think the BMS is now toast. Absolutely cactus, which is a bit of a shame, but also thank God the Daly BMS is actually gone. And I think I have a JK 300 amp BMS, which we can put in this box here and reconnect everything. And this 300 amp B-series JK BMS has a 2 amp active balancer, so we don't need this 24/7 running active balancer in this box here anymore. We can use the one built in the JK BMS. So let's see if we can replace this BMS with a JK BMS and make this battery work again. Yo, I found it. It's a JK B2A, so 2 amp active balancer, a 8S, so 4S 8S BMS, 300 amp PHCR. This is the one which can connect to the parallel PCB and communicate with your inverter or other BMSs via via RS485. It can communicate with your inverter though. 4 millimeter, no. 4.5, no. 5.5. Yes. Cell number 1, 3.2. Cell number 2, 3.2. Cell number 3, 3.2. Cell number 4, 3.2. There is no 2.4 and 3.9 volt epoxy board. That's the whole BMS. Maybe we can take off this carrier here as well. That's the end of the Daly Smart BMS lithium iron phosphate 4S 12 volt 250 amps, charge current 125, discharge 250. I was pumping around 150, 160 amps into the Peter inverter, so far below the 250 which is allowed. If we can make this work somehow. That looks actually not too bad with these holes. They're almost lining up with the old holes. Let's see, this was the negative going to the battery like this. If I drill 3 holes here and have a bit of a standoff, I can reconnect this bus bar directly to the BMS and this back to the negative of the battery. And then we've got the P negative side going back to the load. And I should have not sure what to do here, because we can also not exceed this thickness. The JK BMS is a lot thinner than the Daly, but with these bus bars connected, oh, that's not gonna work. I need to find a better solution. So I've now made these 2 narrow aluminium strips and drilled some holes to mount them on the brackets here for the battery. And they also have some countersunk holes to hold the BMS. And I just used a 4mm tab to put a thread in this bracket of the BMS. The old brackets were a lot thinner. Yeah, with the old design, these brackets were sitting under the epoxy holding the BMS. And the epoxy sheet was holding the brackets with the BMS. And we can see here, there's already a piece missing, because this Daly BMS is very, very heavy. And it was basically only holding on these 4 corners through the epoxy sheet, which is very thin. But now we are putting these aluminium stripes directly on the mounting points of the battery case. So this epoxy sheet doesn't hold anything anymore. It is a pure insulation board now. We could even leave it away because there's already an epoxy sheet underneath. Yeah, because the thread which is standing out here on the aluminium is not very high. Let's see if we can actually fit one of these nuts back on, if it would work. Yes, it does. Okay, now we leave it on. It is a bit of a double insulation here, no problem. Bombenfest. Alright, the BMS mounted. We need to modify these cables here a bit. That is a 50mm ring lock. It is a bit loose on the 2-gauge wire, so I'm taking a 50 and 35mm die in the crimper. That is a really good crimp, because you can see a little tiny bit of excess material. So that means the ring lock and the copper itself was just too much to fit between the 50 and 35mm die, and it squeezed a tiny bit of material to the left and right. It is not much, so I don't need to file it or cut it or something, but this tells me already this is a very good crimp. Beautiful. I don't have blue heat shrink though. So I made 2 bus bars, drilling 3 holes so they fit these ones, and we just put them on top, and this will also connect our cable to the negative of the battery. So I'm just testing if the negative cable actually still fit, and it does fit. Look at this, it's not bad. I need to pay attention here that it doesn't touch the case of the BMS. So, like this. And now comes the fun part. We are taking off all this Gewürre because we don't need it anymore and put our own balance cables on. We are doing it the quick way. So there are two pairs of cable connected to each of the battery poles. One of them was for the BMS and one of them was for the active balancer. We don't need any of this anymore, and certainly not a Bluetooth module. There's also a temperature sensor glued to the top of the batteries. We don't need it anymore. Oh, this takes a bit of heat. I don't think my soldering iron is strong enough to melt this, because there's a bit of tin copper welded to the aluminium in it, and it sucks up all the heat, so it's very hard to melt this solder. It just works on highest setting. That is probably not good. One of these thin bus bars came off of the aluminium bus bar. I don't know if my spot welder can do that and weld it back on, because this is aluminium. I don't think it will work. Well, if it doesn't work, we have to drill a hole in here and put an M3 thread in, and then use the balance cables with a ring lock. Alright, let's see how this goes. Nah. It doesn't stick to the aluminium. Alright, you have to be careful not to drill into the battery underneath. In fact, we should put some insulation material underneath, because when I drill through and touch the case of the battery cell, we're making a short between this cell and the case of any cell I'm touching. So I need to be really careful. Alright, that's done. M3 thread. Let's see how far we come. Alright, that's deep enough. Let's see if we can get a screw in. Yeah, works a treat. Let's see what voltage do we have between the case and the bus bar. There's no voltage. You can't even see it. There's no voltage. But the other case next to it has 3.2 volts. Beautiful. We don't want to touch that. So this one is fine. This one is not. So if I measure from one case to the other, we have full battery cell voltage here, 3.2 volts. That's why it is so important to have insulation material in between the cells. Alright. There's our balance cable bus bar repair result. Alright, so balance cable plug into the BMS and going in a nice string of cables around here all the way at the top of the battery. That's the maximum length we need. So in theory we can cut them all here. In practice as well. We need negative, cell number 1, cell number 2, cell number 3, cell number 4, and the very last for the positive of the BMS. And we don't need 5, 6, 7 and 8 at all. There we go. Alright, let's see if we have done everything correctly and measure the battery voltage. Okay, cell number 1, 3.2, cell number 2, 6.4, 9.6 and 12.8, and the last one for the power, 12.8. Nice. All good. So after testing all the balance cables and made sure the voltage order is correct, I've connected now everything back to the BMS and have used some of this heat resistant fabric which was around the balance cables already in the old setup. Yeah, and cleaned this a little bit up here. Isolated the heating port, which we don't need, so it will just stay underneath here. Connected the two temperature probes, which are sitting over here, and measuring the temperature under the bus bars basically. So everything is ready to go from this side. The only thing now is the power switch, or the power button I should say, because this is a button. Only as long as I press it, it makes contact, yeah? It's a button, it's not a switch. In fact, the old box had a switch. Yeah, this one stays in and connected, and I have to push it again to disconnect it again. This is just a 2-wire cable which was connected to the Daly BMS, and by releasing this button we could actually disable the discharge MOSFETs of the BMS. So this is especially very handy if you connect an inverter, and because the discharge MOSFETs in the BMS are turned off, you're not getting an inrush current. So you connect your inverter here and then turn on the discharge switch again. And the BMS then takes care of the inrush current. So there's no sparking, no fear, no tears. Yeah, but unfortunately the JK BMS uses a button and not a switch. So we cannot use this one anymore. I mean, we could. To turn it on, you do wait for the beep and then turn it off again. So give a short pulse onto the BMS, it turns on. To turn it off, you do the same again. You push this one in, wait until the BMS turns off, and then turn off the switch again. It is not ideal, so I would rather replace this one here with a button. But because this existing switch lives down in the bottom of this box, I would need to take everything out. I mean everything, literally everything. All the cables, all the connectors, the Andersons, everything needs to come out to reach down here. And I also would need to design and 3D print an adapter, yeah, which covers this larger hole and has a smaller hole inside for the button. We are a bit on a crossroad at the moment, so to take all the cabling out, it is a lot of work. Or we can just live with it and solder these 2 wires onto the button of the JK BMS and use this switch mechanic to turn it on and off. Yeah, my friends, last night I got the shits and I said, we are so close now. I designed and 3D printed like a little ring adapter thingy. It looks like this here. It has a little knot, so it clamps to the front panel of the box. And this should give us now the right size for the switch. Why is this cable so... it's building up inside. Oh, that's a bit... That is a bit too tight. Damn it! Damn it! That might be already enough. There we go. There's our button. Not too bad. Okay, so now I have to put all this stuff back together and connect all these cables back to these USB and 12-volt sockets. This will be a total fucking pain in the ass. And we also can take out the active balancer, which is mounted to the side wall of the box here, because we don't need it anymore ever again. Alright, after 20-25 minutes or so, I finally managed to connect everything back in place. It is a bit of a pain in the ass because you have to take off all these other gear to reach this bottom screw there. There's a little bit of a bus bar down there where all the negatives come together. For all this equipment here, for all these 12-volt sockets and USB connections and stuff like this. So everything comes down to this negative bus bar. There's also a positive down there. There you can see the screw. So it needs to be mounted in a certain order. But now everything is back in place, and we've got the positive here connecting to the battery and the negative here going to the BMS. Exactly. And we've got the cable of the button to connect to the BMS as well. So 3 more cables and we are done. But before we put the battery back in the box, we should actually test if the BMS works at all. So let's connect the negative to the negative of the battery. And we just plug in a little display, because this one has a button here to turn on the BMS. Of course, it's underneath the balance cables, of course. Okay, connected. Negative connected, balance cables connected. Press the button. Oh, we got a beep. 0%, that's not good. 12.8 volts. Let's have a look on the app. Must be this one with a number here. It does. Modify password in time. So let's see what we actually have. about. That's the version 17 of the JK B-series BMS. Software 1706. I think we flashed this one before. Yeah, power on times 10 times. Total on time 19 hours. Yeah, we have done some testing with this BMS before. All 4 cells are showing up with the correct voltage. That is all good. 40 ampere hours. Okay, we need to change some settings. So we have a capacity here of 200 ampere hours. BMS needs calibration. Yeah, I know. Balancing down to 10 millivolt delta is fine. Start balancing at 3.45 with 2 amps. 3.65. RCV, I can set this one here to 3.6 volts. Because we're not using any communication with this BMS to something. And we can set this one here to 3.45 volts. The undervoltage recovery state of charge 0 is at 2.7, undervoltage protection 2.5, and turn off at 2.49. Continuous charge current 100 amps, that's fine. Continuous discharge current, okay, we need to go higher here. We set this one to 250 amps. I'm not sure 250 amps is actually a lot for these cables inside this box. This Anderson connector here at the front, when you have a look again, there is a 175 amp Anderson connector, but the cabling is only like 16 mil or something. I mean, even the main cable to the battery is only a 2-gauge wire, which is not even 50 square mil. Ooh, I know the silicon cable, it can carry a bit more, but it will get hot as well, and you don't want any heat inside this box either, right? So 175 amps, I would have gone with a 70 mil cable with a 1-gauge wire. But hey, it is what it is now. Yeah, we set this to 250. Okay. Temperatures, yeah, we need to see what the temperatures are doing inside this box then. Device address, RCV timer for half an hour. That should be enough to fully balance this battery. The RCV timer is only interesting for the reset of the BMS to 100% state of charge. So it needs to sit on 3.45 volts for half an hour. And then it resets to 100%. I think we have to change this back again here to 3.45. Because if we set the charge controller to 13.8 volt, which is 3.45, the cells will not be sitting at 3.45 all the time, especially not if they are load connected, yeah? So there's voltages going up and down a little bit, and if it goes under 3.45 volts, the timer is not running. So it will never reach this half an hour of absorption time, and then it will never reset. So you set your 100% reset voltage a little bit lower to what you actually charge to. Alright, so all the relays, that is not important, not important, not important. Control, everything is turned on. Display always on. There's no display. Would be actually cool to put one of these displays in the box, right? Somehow. Maybe later. Charging float mode. Well, it doesn't matter. Smart sleep on. This is actually a good thing because the BMS will turn off if the battery is not in use. Here's smart sleep voltage 3.5. So if the cells are under 3.5 volts, it will take 24 hours and then the BMS basically goes into deep sleep and shuts everything down. So basically every time I don't use the battery for 24 hours, it goes into sleep. That's fine. That's cool. So the timer should be actually running now, right? Yeah, we can see it here. Time enter sleep. Another 86,344 seconds. So it is running. Cool. Now that's good. That's what I like. And if not, I can adjust it here through the app now very, very easily. All right, that all looks good. Let's turn off the BMS again. Hold the button. All right. Amazing. Take this one off. Oh god, that's a pain in the ass. You need to push this little, and you need a small screwdriver and get behind it and push this little clip so it releases the cable. Alright, that's all good. So what we can do now is we can actually mount this one here. Yes, we can. B negative goes on top, the B negative of the battery, and this connects to the BMS. I really don't have any torque settings for this BMS here, so I'm just tighten them carefully and make sure the cable is not touching the case of the BMS. Yeah, that's all good. Here the main negative, no torque settings, just tighten it. Don't over tighten it. These ones are okay. Yep. And we just need to connect the P negative now and the positive, and we are done. It's actually a bit of a shame that there's no fuse inside this battery box, you know. We have some... No, they are all too small. I have some T-class fuses here, but they are for 48 volt boxes, 150 amps, which wouldn't be enough anyway. Yeah, there should be like a 400 amp fuse or something inside, which is capable of breaking this lithium iron phosphate battery. But hey, maybe at a later stage. And we will use this epoxy board to cover the BMS later, so there are no exposed parts pointing to the case. Alright, so we just need to connect our switch cable once again under the balance cables. Make sure it clicks. And the P negative going to there. Alright, pop this all back in. It can walk. Oh, just positive connected. I can't remember whether or not some covers here covering all this stuff a little bit. Is there anything in here? No, there isn't. Some foam situation on top of the positive and negative. I'm sure I've got a spare epoxy sheet or something which I can just put on top of the battery here to isolate it against the lid. And this is a bit too open for my taste. Yeah, they have these plastic caps sitting on the screws of the battery, like this. So there's a bit of insulation, but all this is totally exposed. So there you go. So this goes on top of it, the lid pushes it down. There's no need to mount it something or glue it or whatever, because we've got these foam cushions anyway holding the battery in place, and this thin epoxy sheet just goes in between. It's just another layer of insulation, so it should be good. Anyway, I'm not going to mount the lid at this point of time because I want to do some thermal testing with this battery here. So next step would be to actually turn it on, right? See what the heck is going on. We can toggle all these ports with this switch. We've got a voltage reading of 12.8 volts, USB C and A, and 3 12-volt outlets. I wouldn't call them cigarette lighter sockets. I know. That's a big one. That's a big one. That's a smaller one. 15 amp. 2 Anderson connectors, 50 amps each, and 175 amp Anderson here at the top. This one doesn't toggle Bluetooth. No big deal, the Daly didn't either. Just hold it and turn it off. There you go. Or alternatively, it turns off now automatically after 24 hours if no power goes in or out. Okay, welcome behind my little driveway charging station here. It is just one solar panel. And there's one of these terrible PO Keeper MPPT solar charge controllers connected. They are really not great. This is the third one I have now. They replaced 2 already. This is the third one. It has a bit of modified software. The other 2 didn't make it. They last maybe half a year or something, and then they just stop or have software issues and don't charge anymore, or showing an error under voltage. Even the battery is connected and there's no under voltage. So I cannot really recommend the PO Keeper series solar charge controllers. Definitely not worth buying. I thought I'd give it a shot because they were cheap. They were like $35 or something, so half price of the Victron, but nah. Anyway, it is charging, or it has charged the salt battery here I'm using from time to time. It's a 12 volt 50 amp per hour sodium ion battery, and there's no current flowing anymore because it has reached the 13.8 volt, I guess, and it has fully absorbed 14 volts it has, yep, fully absorbed, and that's basically it. All right, disconnecting solar first, because that's what they like. Put the big boy in the charging station, and I'm using this Anderson XT60 adapter cable I made. So this plugs into here, and the other one plugs into the MPPT, and we can see nothing because the BMS is not turned on yet. So as soon as I do that, MPPT comes on, starts up, and we have no sun because MC4 is still disconnected. So plugging this one in now, and we have a bit of sun. Let's see what we get. 1.4 amps into the battery already. The panel is fully shaded at the moment, so it may take a while to charge up this battery. We've got 12.9 volts. Not sure how full the battery actually... yeah, I said I've discharged around 1.5 kilowatt hours from it, and this one has nominal capacity, nominal energy 2.56 kilowatt hours, so could be at 40% or something. Yeah, it may take a while to fully charge this battery now, but as I said, the sun is just coming around the trees now, and we will have full sun on this panel, and then we charge with 10 to 12 amps into this battery. But it still may take a day or 2 or 3 days maybe to fully charge the battery, and then we hook up the FLIR inverter and do a bit of a thermal test and see how all the cables hold up at 160 amps. Let's see if we can get somehow into the Daly BMS and have a look what's going on inside. I've never seen one from the inside. Ah, here we go. It comes apart now. There we go. So this is all aluminium heatsink. That's a massive heatsink. Got some thermal rubber, MOSFETs, and everything else seems to be glued. Oh, there's a big crack here in this. Oh no, hang on. This is just... Is that just a rubber layer? Ah, this is all cracked. Look at this. There's a big crack going along here, over there. That's the whole plastic. I don't care. We just wedge our way in. There we go. That's the other part of the heatsink. More thermal rubber. Yeah, oh, the whole plastic is cracked. Look at this. It falls apart. This is all brittle. It looks like the whole PCB is somehow cracked. Yeah, that's basically the end of it. It is totally sealed into this plastic. Let's see if we can get underneath here a bit. Yeah, definitely a non-repairable device. Oh, that is horrible. Yeah, the whole PCB snaps now. Yeah, there it is. That disconnects the PCB and the controllers from the MOSFET side. The official end of the Daly BMS. Now that we have finished this project, just remember that Muller Energy has actually sent me these JK B-BMSs a while back. We have tested both of them, yeah? So one of them actually connects to an active balancer and controls it the same way as you control the internal passive balancer. So it turns it on and off, which is pretty cool. But look at the size of these ones, especially this one here. That's a 250 amp JK B-BMS. This is huge. And this one is a 250 amp as well. This would actually fit maybe. But now the JK is already there. But with this one, I actually believe it can handle 250 amp. That is massive. If you're interested, I'll link all these Muller products down in the video description. I've made a couple of videos about all these devices and batteries they sent me. So it's pretty much all very interesting stuff for camping, off-roading, RV situations and stuff. Really high quality gear. Yeah, there it is. Balancer. It says here, balancer. That's where the balancer connects to. See, it's only a 2-pin connector, and then it turns on the active balancer when the balancer in the BMS turns on. That's actually a pretty cool solution. It's a modified JBD. So Jabata actually built this one here especially for Muller Energy in Sydney. Oh yeah, and this one has the balance connector as well. Very cool. Alright, let's see what we have here in the BMS. You can see 2 amps, it says. And the MPPT says 2 amps as well. So must be true then. 25 watts we get. Cell average 11 millivolt deviation, remaining capacity. Okay, the state of charge is not up to date at the moment. Sleep timer has now reset to 24 hours, 86,400 seconds, perfect. And I think when I disconnect the solar panel, as soon as I stop charging, yeah, the timer starts, see? And now 24 hours later it would turn off. And then when I turn on the solar panel again, it takes a moment. MPPT kicks in and it resets again. Perfect. That works quite well. Balance wire resistance is all good. Yeah, it all looks good. 14.1 degrees we have and 15 inside the BMS. All right, let's keep it charging and wait a little bit longer. Again, so we are charging with 4.1 amps into this battery. It may take a very long time to fully charge it. We've got some bit of clouding coming up now, so the sun is not great anymore here. I'm really considering taking the battery inside and connecting it to the 20 amp charger. I really want to do this discharge test and see how the temperatures are inside. At the moment we are 19, 22 degrees, so that's all fine. But yeah, charging is not great. See, it goes even down. I need more panels here. That's an alternative. Ah, now the sun comes back. 13.5 into the battery now. That looks much better. Okay, we'll see how it goes. If it gets too cloudy, I'll take it inside and connect the power supply. Let's have a look at the big system in these conditions. 6.5 kilowatt we are making here from solar. That's not too bad actually, considering there's a bit of clouding happening at the moment. It's 114 amps outside. Guys, winter is almost over, I tell you. I can already feel it.
The next day.
Yeah, good morning guys, welcome back to another wonderful day here in sunny and cold California. As always, a bit of cloud situation, and it's supposed to rain this noon actually for a couple of hours, but I can't see from where. But maybe it's still changing, I don't know. So as you have seen, I brought the battery in from the outside, from the charging station into the garage and have disassembled it as far as I could. So battery pack is out, cables are connected, everything is ready to go. I have also connected the good old Peter inverter here. It's a 12 volt, 3 kilowatt inverter, one of the best. I've got this here for years, running all my electric gear and tools here in the yard. Electric chainsaw, garden mulcher, everything, you name it. I plug this in and it just runs. So this is already connected to the battery. The BMS is turned off, yeah? And I have connected the cables and there was no spark whatsoever, nothing. So we have actually a similar function as we had with the Daly BMS. If you turn off the BMS and you connect the cables of your inverter, there's no spark, there's nothing, no inrush current. When we now turn on the BMS, it will handle the inrush current. I could hear a small click inside here. So we are now powered. As a load, I have plugged in the Tesla already, so we can adjust the charging current and can put different loads on this battery. All right, let's turn down the charging current in the vehicle to 5 amps and I'll turn on the inverter. And the car should start charging straight away. Here it comes. And we are now charging. Let's have a look in the Muller 12-200. What's going on? So this is now 100 amps. Do we have the power somewhere? I'm sure we have. Yeah, down here, 1.2 kilowatts it is. I'm sure 100 amps will get everything nice and toasty and warm. But we want to go a bit higher. 100 amps is not that much, 1.2 kilowatts. So let's go to 6 amps in the vehicle and see how this changes. So if we increase the charging current in the vehicle by 1 amp, we are increasing the discharge current of this battery by 25 amps. Alright, let's go one higher to 7. 7. Oh, software update. And this should bring us to 150 amps. I think this is a good discharge current for this battery. I'm not sure how long it will last, because the cells are already at 3.1 volts. Let's have a look at the status. So we are at 13, 14 degrees, 16 degrees here in the BMS. Obviously everything is exposed now, so it is a bit easier for the battery to handle all that. But yeah, let's leave this running here for a while, then use the thermal camera and see if we can discover any hotspots here. Just touching some of the terminals, but everything seems to be fine at the moment. Yeah, this one gets already a bit warm here. Yeah, okay, leave this running for a couple of minutes and then we have a look with the thermal camera if we can spot anything. Okay, my friends, we are running now for 20 minutes and the battery voltages are just dipping under 3 volts. Let me quickly show you, and then we turn on the FLIR camera to see what's going on. Yeah, 2.8, cell number 4 is at 2.8, so we need to do the thermal stuff now, otherwise we won't see anything. This is all only hand warm. Okay, let me start the FLIR. Alright, so there we are, that's the infrared camera, and we see 32 degrees on the cable. Nothing so much on the BMS, there's a bit of heat building up here on this ring lock. But what are we talking about? 30 degrees at the moment. The battery itself is fine. Yeah, and here as well, these are the ring locks and the cable, the 2-gauge wire. And there should be nothing happening inside this box. What are we talking about here? It's the cable again, 30 degrees. No, but that's all fine. I think this is the configuration I would run the battery with. So connecting everything directly to the 10 mil terminals at the outside, and then having the PIDA inverter doing all the work. Yeah, but so far everything looks good at 150 amps. I don't think there are any thermal issues or so. It may look a bit different in summertime when we have already 35 degrees outside, but the usage of this battery with this load is very limited because the electric chainsaw and the garden shredder, they are not constantly running at full speed, at full power. So I don't think we have any problems. BMS is nice and cool. It runs only on 50% of the capacity anyway, so that's all good. Alright, back on the screen recorder. We are 106 amps only. 0%, and now it has turned off. Yeah, one of the cells has hit 2. No, the inverter has shut down actually, because we've got a cell deviation of 280 millivolt, which is quite high, but the battery hasn't been properly top balanced for quite a while. The Daly BMS does not balance anything, and the active balancer inside did more damage than it actually did good. So we have to fully charge this battery, fully top balance it, and see what's going on. But yeah, so far I'm pretty happy with the performance and result. There are no thermal hotspots, no heat issues, nothing like this, so this is all good and working perfectly fine. Alright my friends, I think so far this video, this successful transformation of this battery, this upgrade from the old Daly BMS, the 250 amp Daly BMS with a 300 amp JK B-BMS B-series with active 2 amp balancer. So pretty cool. And what I also spotted is the BMS is actually hovering a bit over the epoxy sheet here, while the Daly BMS was directly mounted on the epoxy sheet. So there's actually a bit of airflow between the BMS and the battery now. Thanks to our aluminium strips we put in, we have raised the BMS by 3 millimeters off the battery. So there's actually a pretty good side effect. I don't think I would have been able to install any of the JBD BMSs in here. Maybe the smaller one would just fit. But maybe next time when we replace the JK BMS with a JBD BMS again, if this ever happens. Yeah, there's always a bit of mechanical work necessary to mount the BMS inside such a box. Because of the limited space in such a box, it can be very tricky, but in this case it was fairly straightforward. Just some aluminium strips left and right, which are holding now the BMS in place. And we also upgraded the whole battery box with some epoxy sheets, so all the battery cell terminals are now covered. Nothing is exposed to the metal of the box. So overall I'm pretty happy with this repair and upgrade. Yeah guys, let me know in the comments down below if you had a 12 volt battery with a faulty BMS and have repaired and upgraded it to another BMS. Let me know in the comments. Guys, thanks for watching, thanks for all your overall support here, more videos are on the way. If you are new here, consider subscribing, smash a like, leave a nice comment. And guys, until the next video, you stay charged, stay safe, and thanks again for watching. See you then, bye bye.